Here in section A, you have classical mechanics and relativity, and waves and optics. These are the two set of main topics. And in section B, you have electricity and magnetism, and you have thermal and statistical physics. For optics, only one book. Ajay Ghatak, only one book. But ये subject आप appreciate तभी करोगे जब हमारा ये part clear है. Physics dedicatedly नहीं पढ़ा है, then आप न्यूक्लियर फिजिक्स नहीं पढ़ते हो. इनफैक्ट आप एटॉमिक एंड मॉलिकुलर, जैसे आपने क्वांटम पढ़ा होगा, वेरी श्योर कि क्वांटम के कोर्सेज किए होंगे. अ गुड आंसर विच आई वाज टॉकिंग अबाउट, प्रेजेंटेशन मैटर्स अ लॉट. Having an initial velocity v0 subjected to a retarding force proportional to its instantaneous velocity. Obtain the expression for the velocity and position of the particle as a function of time. Hello, good afternoon. Welcome to this open session. In today's session, we are going to talk about physics as an optional subject for UPSC. The main purpose of this session is to first familiarize ourselves with the subject, and especially the significance of this subject for UPSC. So we are going to talk in detail about the syllabus of the subject itself. I'm also going to show you examples, what type of questions UPSC expects. I also have detailed model answer for many questions, but of course we cannot discuss model answer for all of the questions. I have, for example, model answer for the 2024 paper. So I will show you some of the model answer, like how you are supposed to present your answer in a limited space. Okay, so that will also be one part of the session. And I'm of course going to also talk about briefly, now that we are going to finally launch the subject here at Vision IAS, I'm briefly also going to talk about how I plan to approach this subject for students who are deciding or have decided that physics is going to be their optional. So let me tell you a few things about myself. My name is Abhishek Kumar. I have been teaching science and technology and environment at Vision IAS for last 7 years now at Vision IAS. In fact, my association with Vision IAS predates that, but full-time teaching I started in 2018. So yeah, 7 years now. And before that, so I am from Bihar. I am from a city called Muzaffarpur in Bihar. And I did my graduation, high school and 10+2 from Bihar itself. But I completed my BTech from IIT Delhi in 2011. And my specialization was in civil engineering. So while I was preparing for my JEE examination, I was blessed to have a great teacher, SN Sinha sir, and he taught physics when I was preparing for JEE. And that interest in the subject, that remained. So I thank him a lot. Like I often think about him a lot, and he was quite old when I was his student. But he was a remarkable teacher, and I had genuine interest in the subject, which is thanks to him. So even when I pursued my BTech, I kept taking some, because when you do your BTech at IIT, you have a lot of flexibility that you take some electives also. And many of my electives were physics. I had some stint, I worked for a few years after my BTech, but I prepared myself and physics was my optional. Unfortunately, it was not meant to be. So here I am. And now I'm going to start physics optional here, right? So one more teacher who I would like to credit a lot in my journey as a student, because I still think of myself as a student. I still get to learn so many things. And one teacher which I think everybody who is interested in physics, and I'm very sure many of you already know that, is a retired professor from IIT Madras. And I have never studied from him face to face, but I have simply watched his lectures on YouTube. And so Government of India has a program called NAPTEL program. Dekha aap logon ne? NPTEL. So there are a lot of courses available by Dr. Balakrishnan. So I'm talking about Dr. V. Balakrishnan, and he is retired professor for IIT Madras. And he has courses on classical mechanics and quantum mechanics and mathematical methods in physics. And he has beautiful courses, and like I'm just a huge fan. And I feel like that this is how this subject should be taught. That you realize that physics is built on mathematics, but physics is also not mathematics. This distinction is very important because mathematics relies upon many axioms. In physics, you do not have axioms, do we? We do not have axioms. In physics, we have theories, and we always ask questions, and we always modify our theories based on the new data sets we have. So it's very important to acknowledge this difference. So when I do mathematics, and I come to certain solution, and I plot my data, and I find some trend, then I try to understand the physical significance of that. So my goal as a teacher, and I am again trying to replicate, and I hope that I will be like even a fraction of that percentage, I will be able to do that. My goal here will be that when you choose physics as an optional, it shouldn't feel like a burden. It shouldn't feel like that, now these are the derivations you need to do rote memorization, and you need to remember, and you need to exactly write them down, everything. Of course, you have to do that, but I want also you to enjoy the subject. That there is a reason why you chose this subject. You had a background, you like this subject, and you want to use this subject in your goal right now, which is UPSC. So I want this process to be fun. I want this process to, that you actually be happy about this, and you score more than 300 marks, which is, by the way, very much doable in physics as an optional. Okay. So anyways, coming back to the PPT itself, coming back to the presentation, coming back to the session itself.
Most UPSC aspirants fail before they even begin. Here's how you avoid that. The mistake: they jump into preparation without a roadmap, a mentor, or a clear strategy. At Vision IAS Delhi, we help you build your UPSC foundation the right way from day one. Get structured coverage, prelims, main CSAT and essay, all broken down step by step so nothing feels overwhelming. Smart current affairs with PT 365 and Mains 365. You focus only on what truly matters, no fluff. Personal mentorship, real one-on-one guidance to help you fix weak areas and boost what you're already good at. Test plus feedback loop, regular tests with detailed feedback so you never lose track of your progress. Don't start blind, start smart with Vision IAS Delhi. This is where your serious UPSC journey begins.
UPSC preparation is not just about reading books or watching online lectures. It requires personal guidance, real discussions, and structured practice. This is where offline mentoring makes all the difference. Unlike online learning, where doubts often remain unresolved, offline mentoring offers direct interaction, real-time feedback, and an environment of discipline and competition. One-to-one sessions help students get tailored advice, strategy corrections, and focused improvement. Every aspirant has different strengths and weaknesses. Personal mentoring helps address them effectively. Ground discussions sharpen analytical thinking and help students develop a multi-dimensional perspective on issues crucial for prelims, mains, and interview. Elocution sessions help in personality development, clarity of thought, and confidence, essential for UPSC interviews. Test writing is the most crucial part of UPSC preparation. It helps in time management, structuring answers, and improving content quality. Offline mentoring is not just about teaching. It's about grooming future officers with the right guidance, discipline, and confidence. So if you are preparing for UPSC, make sure you have the right mentor by your side.
I'm going to divide this session into mainly 3 parts. I'm going to first talk about this subject and the requirements for UPSC. Second, I'm going to use some example, both in terms of questions as well as model answer. And third, I will not spend a lot of time, but third, we will briefly talk about that how I plan to approach this subject here at Vision IAS, that we are going to start the subject on 20th of July. Okay, so let's talk about the syllabus first. Let's talk about the syllabus of this subject. I'm very sure that you all have gone through this. I wanted to tell a few things, what I think about various subjects. Like all optional subject, you have 2 papers, and both papers are divided into section A and section B. So that is common in all optional subject. Here in section A, you have classical mechanics and relativity, and waves and optics. These are the 2 set of main topics. And in section B, you have electricity and magnetism, and you have thermal and statistical physics. While in paper 2, in section A, you have quantum mechanics, atomic and molecular physics. And in section B, you have nuclear and particle physics, and solid state physics, devices, and electronics. So this is like the main part of it. Let's look at the nature of the questions. You are supposed to attempt 5 questions out of a total 8 questions. Again, this is same in almost every optional subject, that 8 questions will be given. However, in every question, there will be more questions. There will be 4 questions in section A, 4 questions in section B, both in paper 1 and paper 2. And every question will have many sub-questions. So question 1 and question 5, they are mandatory. They have 5 questions, they contain 5 questions, and those 5 questions will carry 10 marks. And out of the remaining 6 questions, you have to attempt 3, choosing at least 1 from both section A and section B, not counting question number 1 and 5, which is mandatory. This is the standard framework UPSC uses for all optional, almost all optional, including into physics. Okay, so our goal here should be to be good at each and every part of the syllabus first. Because only when you are good at every part of the syllabus, then you become better at choosing the right set of question in the examination, that you can attempt that into 3 hours. So I do not, the very first, even before I start the session, I do not abide by this idea that let's ignore electromagnetic theory, or let's ignore solid state physics. I do not abide by this idea. This is not going to help you. You'll have to leave question of 20 marks in paper 1 or paper 2, and that's not very good. You should try to attempt all of the questions in both paper 1 and paper 2. What type of questions? Generally 2 types. Standard derivations. There are many standard derivations which are asked. Standard derivations often are of 15, 20, or even 25 marks. However, sometimes a very small derivation can also be asked as a 10 marker. So I have used the word generally. So a larger part of your question will be standard derivations. There are some standard derivations which you will have to do. Even within numerical, I can further categorize this numerical into 2 groups. You have some numericals which are standard numericals. You have fixed set of numericals, and UPSC does not depart a lot from that fixed range of things. That's a good thing about physics as an optional. But there can be some numericals which can be entirely new. And particularly in paper 1, that will be true. In paper 2, not so much, but in paper 1, you definitely will find many numericals which UPSC did not ask earlier. So we should be prepared for that also. So you can have numericals. Most of the numericals, particularly from that mandatory section, question 1 and question 5, that will carry 10 marks, but sometimes it can also be of 15 marks. But numericals generally are not of 20 marks or 25 marks. That is the standard derivation. Of course, I am going to show many examples about that. Okay, so let's talk about the syllabus briefly, step by step, and what I think about the syllabus and what I think about the nature of different section of the syllabus. The first paper 1 section A. So if you look at the UPSC syllabus, then both paper 1 syllabus, they have done a very good demarcation of things, but they have not done the same thing in paper 2. So I have tried to demarcate paper 2 in the same way what UPSC already has done for paper 1. So this will make a lot of sense even in paper 2. So let's start with the very first part, mechanics of particles. Very basic ideas, laws of motion, conservation of energy and momentum, something which you learn even in your 10+2. And applications to rotating frame, centrifugal, there should be centripetal, centrifugal, and Coriolis acceleration. So the idea of pseudo forces in rotating frame of reference, this is a very favorite topic of UPSC. You'll find a lot of standard derivations here. For example, a favorite question of UPSC is that you drop a ball from some height and by how much it is going to deflect to east or west. These are like very simple derivations you can expect due to Coriolis force. A topic which UPSC is asking a lot of questions from in last 5 years is these two things: motion under central force and conservation of angular momentum, which is almost every central force will exhibit conservation of angular momentum. And Kepler's laws, fields and potential, gravitational field and potential due to spherical body. This was surprisingly, if you go and look at the question paper from 2011 to 2000, let's say 17-18, you'll not find a lot of questions from this. But in recent year, you'll find many questions from this part of the syllabus. Gauss and Poisson equation, this is much more important in your electromagnetism syllabus because you have the same thing in your electricity and magnetism. Surprisingly, even though it is mentioned in the syllabus, UPSC does not ask a lot of questions in classical mechanics. But the topic is important for electricity and magnetism. Why I think classical mechanics, having a very solid foundation of classical mechanics, is important? Because this is the actually first branch of physics which was well established by Newton himself. And then you realize that the ideas which you develop in classical mechanics, you need to apply those ideas in many other branches, even in modern physics, such as quantum mechanics or atomic and nuclear physics. For example, the idea of two-body problem, that you develop this idea of two-body problem, that let's say you have a planet and you have a star, and there are two bodies, but you can reduce that to one-body problem, right? And this idea you also apply in solving, let's say, hydrogen atom. That when you are solving for hydrogen atom and you are solving Schrodinger equation, you apply the same set of idea. So you find physics, one of the beauty of physics is that it is branched, that the ideas which you develop here in classical mechanics, you try to apply those ideas in other branches. Some of those ideas work, some of those do not. And those who do not work, then you try to think outside of the box and you develop new set of ideas. For example, when you study thermodynamics, you need to develop altogether new set of ideas compared to what you did in classical mechanics and relativity. Mechanics of rigid bodies. Now this is something which you generally do not study in 10+2, very specific things you study in 10+2, a lot of things. For rigid body conservation, theory of energy, momentum and angular momentum. Elastic, inelastic collisions, mechanics of rigid bodies. Conservation theorems, energy, same thing, elastic and inelastic. This is a repetition of things which I have. This is a repetition. But this is something which you do not study in detail in your 10+2. But here you have to do, this is from graduation. When you study physics in graduation, then these are the areas which you have to do really well. Mechanics of continuous media. I like this subject, and there is a very good reason, because many of these ideas which you learn it here, you find this application in thermodynamics. Because in mechanics of continuous media, you are not interested in dealing with individual particles of a solid object, let's say. You're looking at astronomically large number of particles, and even though you do not know what is happening to those individual atoms and molecules, but you still can make certain rules and regulations at the bulk level. And this is exactly what thermodynamics tries to do. So the beauty of thermodynamics is that it allows you to come to practical conclusions even though you are dealing with astronomically large number of particles, where your degree of freedom is so large that you cannot practically think about writing solution to each and every particle. But thermodynamics still allows you to come to certain set of answers. So mechanics of continuous media, what you study in 10+2 versus how you should study that, these are two different things. I actually think that this is a beautiful, beautiful subject, and having a very good understanding of this help us in other, just say when you study laminar flow, then you find the same set of application in probability density in quantum mechanics when you study about how probability flows. So the ideas which you develop here, you find applications of these ideas in other branches of physics. Now, even though special relativity is added in section A, but इसका अपना खुद का एक standing है, because this is every year you expect at least 1 or 2 questions from special relativity. So this is a very, very important topic. And even though it is mentioned along with classical mechanics, which by the way, all standard textbook of classical mechanics will do that, but for UPSC, this will have its own standalone standing. Even if there are many questions from classical mechanics, you still will find questions from relativity. So this is a topic which UPSC likes a lot. And how you build, again, why we should study relativity step by step, that how you build the subject, that how you realize that Newton's ideas do not work. Even though Maxwell tried to rectify things, you realize that Maxwell himself realized that not everything he had said is making sense. And he's trying to ignore those things. He's trying to ignore some of the problems in his theories when he developed his idea of electromagnetic theory. He tries to ignore them. But it cannot be ignored. Einstein realized that it cannot be ignored. And then, even though Lorentz developed the transformation idea, but it was Einstein who first thought of this intrinsic idea that space and time are not independent of each other. So that is why special theory of relativity is associated with Albert Einstein. Even though the transformation was done by Lorentz himself. Right? This is the beauty of the subject, where multiple people are thinking in same ideas and somebody finds the fundamental relationship, fundamental laws of nature. So this is a very important topic, special relativity. For this subject, I only recommend 1 book, 2 books in fact. So books you should refer to for this first topic, classical mechanics and relativity. So this is a beautifully written book, Introduction to Mechanics, Kleppner and Kolenko. And this covers almost 80% of the syllabus except the mechanics of rigid body. So mechanics of Hooke's law ka jo ideas hai, laminar flow, jo pura fluid dynamics and jo rigid body dynamics hai. Sorry, not rigid body dynamics, but the idea of elasticity and fluid dynamics. You will not find this here. So those chapters, you can read this in Mechanics by D.S. Mathur. Right. So apart from that, everything else which is mentioned in the syllabus, including relativity, even though I personally find the book written by Resnick on relativity to be much better, but nonetheless, for UPSC, this is more than enough. So for classical mechanics, I think everybody must have this book and few selected chapters from this book. Not the entire book, but few selected chapters from this book. We must have a very good command on classical mechanics, because often when you actually go and attempt questions, you should try to attempt 3 questions from section A and 2 questions from section B. This is what you should, it does not have to be, however, a very rigid framework. ये बहुत clear होना चाहिए कि whatever I am discussing, do not think of this as a rigidity. There is a very beautiful quote by Mike Tyson. Everybody has a plan until they are punched in the face. So when you are appearing in the paper, then we should spend some time then and there that which are the 5 questions I'm going to attempt, and you should stick to that. So take as much time as you want, that these are the 5 questions. So first and 5 to clear hai. But out of remaining 6, which 3 questions I'm going to attempt, इस पे हमको शुरू में ही टाइम लगा देना चाहिए, जितना भी टाइम लगाना हो. Generally you will find that doing that in section A of both paper 1 and paper 2, by the way, 3 questions from section A in both paper 1 and paper 2 will be helpful. But that does not mean we should not take section B seriously. In fact, we should section B very seriously, so that we have the capability to analyze that should I go for section A questions or section B question. So a point I made earlier, that people tend to ignore section B, or at least some parts of section B. The first part of section B is waves, and frankly this is not independent of what we already have established. जो ये discussion है, this is very much part of classical mechanics. This is an extension of simple harmonic motion, is an extension of classical mechanics. This is a beautiful motion where, think about it, in simple harmonic motion, your time period is independent of amplitude. How powerful this idea is, that there is not a single other periodic motion where your time period is independent of amplitude. Think of gravitational force, for example. Remember Kepler's law, larger the distance from sun, more will be the time period of revolution. But simple harmonic motion is the only motion where your time period of revolution is independent of amplitude, right? This has powerful, powerful implications because you realize simple harmonic motion in nature in so many different ways. But then you also realize that simple harmonic motion is an ideal condition. In reality, there will be some damping, and hence reading about damping is important. And of course, we know about at least 3 types of damping. The idea of resonance, which occurs in so many different ways in nature around us. So trying to develop mathematics and trying to make sense of that maths. I will go back to this idea earlier which I mentioned. It is not about the mathematical formula you derive. It is to make sense of those mathematical formula. And I will go back to a statement I made earlier, that physics and maths are not same subject. Maths relies upon axioms, physics relies upon experiments. I need to verify, I should be always willing to change my theory based on the experimental data. Be it stationary waves in a string, pulse and wave packets, phase and group velocities, all of these things is an extension of classical mechanics itself. But by the time you go here, refraction and reflection and refraction from Huygens principle, and then you are entering into this new domain. Again, it is not entirely new. The ideas which you develop earlier, you are going to use that. By the way, I wanted to mention a few things about classical mechanics more. The best part of classical mechanics is not in your syllabus. Anyone who will tell me which part? So, the best part of classical mechanics is not in UPSC syllabus. I'm assuming that you have physics as a background. I showed you the syllabus. So we do not have Lagrangian mechanics and Hamiltonian mechanics. So classical mechanics का जो beauty है, वो तो तभी पता चलता है ना जब आप Lagrangian mechanics पढ़ते हो और Hamiltonian पढ़ते हो. When you deal with abstract algebra, when you deal with abstract space, like what is happening in this space, वो तो easy है. But imagining in abstract space, in phase space, that how things are changing in phase space. मजा तो तब है ना subject का जब हम phase space पढ़ते हैं. So the subject is easy. Classical mechanics is easy because you do not have to, for UPSC, because you do not have to deal with Lagrangian and Hamiltonian, or even though Lagrangian Hamiltonian makes things easier in solving complex numerical, but it is not part of the syllabus. The reason I mentioned that, because when you read principle of least action, and when you read the concept of phase space, so for example, think of the Fermat's principle, that reflection and refraction from Fermat's principle. And you realize that Fermat's principle is not a fundamental law of physics. Fermat principle is coming from a more fundamental law, which is principle of least action. And then you read about principle of least action, and then you find that how this leads to some really beautiful laws with respect to symmetry and conservation. And you read about conservation of angular momentum or linear momentum or energy because of symmetry in space and time. Noether theorem. Have you read Noether theorem? UPSC में नहीं पढ़ना है, but classical mechanics का एक जो बहुत beautiful part है वो Noether theorem है. Noether was a scientist. She was the first who gave this hypothesis कि जो conservation laws हैं उनका एक fundamental reason है that linear momentum conservation जो है, that is because space is same even if I go from here to this place. Conservation of energy is because of time symmetry. Conservation of angular momentum is because even if I rotate my frame of reference, there is a symmetry. So you realize that every conservation law we find, be it angular momentum, linear momentum, energy, or many other conservation laws which you by the way learn in particle physics, there is an underlying natural symmetry behind it. This was the contribution of Noether. तो ये भी आपको पढ़ना नहीं है. You do not have to study that. But I do think that we should be aware about these things to appreciate the beauty of the subject, right? Anyways, the point I was trying to make, that there is a more fundamental principle behind Fermat's principle, which you are not supposed, do not have to read it here, but we should know that. Geometrical optics is very simple. This is the simplest. Optics in general is the simplest part of your section A. And geometrical optics particularly is very simple because you have to study very few things. Even in matrix method, you do not have to deal with more than 2 cross 2 matrix. So matrix multiplications also are very simple. So this is very easy part. And even chromatic and spherical aberration, you have half and page derivations. So this is a very easy part of the syllabus. Even within waves and optics, this is very easy part of the syllabus. Interference, diffraction. The reason we still study about Young's experiment or Newton's ring, even though Newton's ring as of now, this does not have some practical utility, but we study this, that how understanding of light evolved throughout the history of time. So study of these topics is to appreciate the evolution of the subject itself, that how the understanding of light improved via various set of experiments. But now we have, of course, much more sensitive experiments such as multiple beam interference or even Fabry-Perot interferometer. That even though there is a small change in wavelength of light, this device, Fabry-Perot interferometer, will be much more sensitive to those changes. So you want to improve the resolution of your devices. Same thing about diffraction, that how the idea of diffraction evolved first by Fraunhofer, then by Fresnel, and this becomes very mathematical. But the good thing is that here also, UPSC does not expect you to go into very complicated maths. If I go, particularly when I explain Fresnel diffraction, then Fresnel diffraction will include some really complicated mathematical ideas. But for UPSC, the questions are not very complicated. They are very simple and very straightforward, and simple ideas are asked by UPSC in examination. The most important topic within optics in section A is this. The maximum number of questions will be asked from polarization and modern optics, every part. So I will further divide this into mainly 2 parts, but there is a small part called holography. ये हर 2-3 साल पे आपको एक 10 नंबर का क्वेश्चन मिल जाएगा holography पे. बट एक ही क्वेश्चन यूपीएससी ने पूछा holography पे, what is it, how does it work, what are its applications, that's it. So you have to acquaint yourself with very simple ideas of holography. But जो important ideas यहाँ पे हैं वो ये हैं. Polarization and about lasers. So you learn about polarization, you learn about fiber optics, and you learn about laser. So these 3 are the most important topic within optics as a. You expect a lot of questions from this part. So we should prepare this topic really, really well. Every year, there will be questions from one of these topics at least. Okay. Next part of the syllabus, section B. So that was section A, section B. Section B is electricity and magnetism, further divided into 3 parts. First is, let's not try to focus upon time evolution of things. Let's focus upon a charge which is at rest or a magnet which is at rest. So in the first part of the syllabus, we are not interested in dynamics. We are interested in electrostatics and magnetostatics. So let's not focus upon the time evolution. We will do that in current electricity and electromagnetic theory. Right now, let's focus on simply stationary charges and magnets. Because these ideas actually make you better at the next part, which is particularly electromagnetic theory. So only when you understand the foundation of electrostatics, and I start with a very simple idea of one charge, or point charge, but then I apply this to a charge distribution, and so you develop Laplace or Poisson equation, which can be now applied everywhere. You learn about the energy of a system of charge. You learn about this very unique method to solve the problem of potential and as a result electric field, which is called method of images. You learn about dipole. You learn about dielectrics and polarization. And then you start finding this connection between the previous subject. That I think of electrostatics as fundamental as the classical mechanics itself, right? Because you find the interconnection among subjects. That the idea of electrostatics and magnetostatics, then you apply this in polarization, which now has applications in optics, and it also has applications in electromagnetic theory and radiation in general. Same thing which we do for charge, we also try to do the things for magnets, and we try to understand this interconnection between electricity and magnetism. I should tell you one thing here. Magnetism as a concept was only saved by Einstein, even though magnetism was discovered 300 years before Einstein. But the fact that electric and magnetic field are not two different things, even though Faraday concluded that there is an electromagnetic field, Maxwell concluded about electromagnetic field. But even then, the very fact that these are not two different things, this was only explained with help of special theory of relativity. So there is a very deep interconnection between electricity and magnetism, and that interconnection is special theory of relativity. UPSC does not ask question on this, but again, this is an idea which we all should be very clear about, that there is a deep interconnection, and you only appreciate that interconnection when you study special theory of relativity. In UPSC, magnetostatics is very simple. 2-line syllabus is given here. Magnetic shell, uniformly magnetized sphere, ferromagnetic materials, hysteresis and energy loss. Hysteresis, this has application also in thermodynamics. So again, ये जो हम पढ़ेंगे अभी, some of these topics, they have applications in thermodynamics. This is easy. Kirchhoff's law, Bytes-out law, this is something which you learn even in your 10+2. Ampere's law, Faraday's law, more or less same चीजें हैं. थोड़े बहुत न्यूमेरिकल्स डेरिवेशंस थोड़े ज़्यादा कॉम्प्लिकेटेड होंगे, बट ये ग्रेजुएशन छोड़ दो 10+2 लेवल का है. इवन लेंस लॉ, सेल्फ एंड म्यूचुअल इंडक्टेंस, what you learn in your 10+2 in your IIT JEE preparation, you learn about the same things. Even AC circuit, DC and AC circuit. The only new things which will be perhaps added here, that in 10+2 you do not read about series and parallel resonance, you do not read about quality factor or principle of transformer. So current electricity is a very simple part. In fact, this perhaps is the simplest part of the section B, because the next part is not simple. This is very scoring. If you have a question from electromagnetic theory, try to, and if you know this, then try to attempt that question. If you know that in a limited time, you can attempt a question from electromagnetic theory, then try to attempt that. Every year there will be at least a 20-mark question from this topic. So this is a favorite topic of UPSC. But इसका जो maths है, वो थोड़ा complicated है. Compared to what you study in optics, what you study in classical mechanics, इसका जो maths है थोड़ा complicated है. Even though some very basic ideas of vector calculus you have to apply even in classical mechanics, but here the same ideas of vector calculus, particularly vector potential, you need to apply that on a much larger scale. So relatively this is a difficult topic. In fact, I would say that maybe this is perhaps the most difficult topic of entire paper 1 because of the underlying mathematics. But again, I will say that when you appreciate the physical meaning of that maths, when you appreciate that the mathematical formula, what are they telling us, then you explain some very basic ideas like even reflection and refraction and total internal reflection and even dispersion or scattering. So these are some of the very basic ideas which you learn. And if you want a solid foundation of these topics, then you should have a very good understanding of the idea of electromagnetic wave. And only then you can also appreciate a very, very important topic which could have also been added in thermodynamics as a topic, which is blackbody radiation. That you blackbody radiation and all of the, so you first study Planck's radiation law, and then you study that how this Planck's radiation law leads to all of those simpler laws which you have already studied in, let's say, 10+2 classes. You already know Rayleigh-Jeans law, you already know Stephen Boltzmann law. So all of this is nothing but a special case of Planck's law of radiation, right? This has direct applications again in thermodynamics. So ये जो section B का ये जो part है, वो मुश्किल है compared to other part of the syllabus, okay? Only one book which I recommend. For optics, only one book. Ajay Ghatak, only one book, right? And even for electromagnetism, I only recommend only one book, which is Griffith's. Everything else, if let's say for example, if you will not find the same way current electricity discussed in Griffiths as let's say in by Satyaprakash. जो यूपीएससी का जो रिक्वायरमेंट है करंट इलेक्ट्रिसिटी में, वो ग्रिफिथ्स फुलफिल नहीं कर पाएगा जो यूपीएससी के जो क्वेश्चंस आते हैं. बट आई स्टिल थिंक दैट करंट इलेक्ट्रिसिटी इज अ वेरी स्मॉल पार्ट. इवन इफ यू कैन गो एंड रीड एच सी वर्मा, क्लास 12 का जो एच सी वर्मा आपने पढ़ा भी होगा, रेशनिक हॉलीडे पढ़ा होगा. इवन इफ यू रीड दैट इज मोर देन इनफ फॉर करंट इलेक्ट्रिसिटी. बट I cannot emphasize enough that how beautiful this book is. This is an amazing, amazing book, perhaps one of the best books written on the subject of physics, and definitely the best book on electricity and magnetism. So there are some really powerful basic ideas. And again, David Griffiths is one of those authors who writes physics like how it should be taught in the classes. Not as bombardment with maths, but with ideas first, and then gradually developing maths around those ideas. So this is a beautiful book. Ghatak becomes a very complicated book in many chapters. The only thing is that for UPSC, we have to read very specific selected chapter. Even in Griffiths, you do not have to read the entire book. I will mention in the classes which chapters we need to study. But here also in Ghatak, you do not need to read the entire book. You need to read very specific chapter. But I find Ghatak to be, again, a very beautifully written book. So rather than recommending any other book, I would go for Ghatak. That we should read optics from Ghatak.
Stop wasting hours on scattered current affairs preparation. Visionized Digital Current Affairs Premium gives you AI-powered answers, expert feedback, and structured revision all in one place. Instant AI answers, no more endless searches, get precise syllabus-aligned insights in seconds. Daily answer writing, expert feedback to sharpen your mains responses. Quick notes and highlights, organize, revise, and retain key concepts effortlessly. Plus, free features. Daily news summaries from the Hindu and Indian Express, quizzes and MCQs to test your progress, and downloadable PDFs for seamless revision. Study smarter, not harder. To know more, visit our website now.
फिजिक्स पढ़ते वक्त बहुत बार एक वोला मोमेंट होता है, पढ़ते हैं हम एक होता है कि लाइक वोला मोमेंट, दिस इज सो अमेजिंग टू नो. फॉर मी दिस वाज व्हेन आई स्टडीड थर्मोडायनेमिक्स एंड व्हेन आई रियलाइज्ड दिस डीप इंटरकनेक्शन विद स्टैटिस्टिकल फिजिक्स. दैट यू फर्स्ट प्रॉब्लम ये है कि व्हेन I was taught thermodynamics. So I told you, Sinha sir, who taught physics when I was preparing for JEE, great teacher, but he did not teach us thermodynamics, right? And somehow I did not appreciate the depthness of the subject, even though I was good at physics. But I did not understand the depthness of the subject when I was a student in 10+2. Very late in my education, I realized that how powerful ideas of thermodynamics are. That it allows us to deal with a system which has degrees of freedom in astronomically large number, more than Avogadro's number, think about it. And how do I solve about such system with such a large number of degree of freedom? And thermodynamics allows you to do that. So सबसे पहले तो यही amazing part ये है that the fact that, and by the way, I also mentioned Professor Balakrishnan, and if you watch one of his lectures, then Professor Balakrishnan has a very funny quirk on thermodynamics. He says that this subject should be called thermostatics. It's not dynamics, because there is no time evolution of things which you study in thermodynamics. In thermodynamics, you always are interested in equilibrium states. That you study, even if things are changing, you assume that those changes are very gradual, very slow, and you can always imagine that the idea of equilibrium state can be applied. So the actual name of this subject should be thermostatics, not thermodynamics. But again, we are stuck with the term here, because in thermodynamics, we do not study about time evolution of things. Okay, and that is, by the way, focus of dynamics, where we study about time evolution of things. So you realize that even with very simple laws, now there are 4 laws of thermodynamics, including zeroth law. Zeroth law People did not even know what does heat mean. Like thermodynamics पढ़ने से पहले आप thermodynamics का सबको history पढ़ना चाहिए कि कार्नोट ने जब आइडियाज अपने डेवलप किए, गिब्स ने जब अपने आइडियाज डेवलप किए, what was going on? ऑटो ने जब अपने आइडियाज डेवलप किए डीजल इंजन के, what was going on behind these ideas? People did not even understand heat, that what exactly heat represents. People thought like there are a lot of theories, crazy ideas about what does heat mean. And then of course later people realized that it should be related with the disorder which is at the atomic and molecular level, and the transfer of it is nothing but a form of energy, right? And you realize, so zeroth law is a very fundamental law. Again, third law is a very simple, not a very simple, that's also a very important statement. But it is the first law and it is the second law which is profound, and particularly second law of thermodynamics is, if I have to say that one of the most fundamental and profound laws of physics, that is second law of thermodynamics, because second law of thermodynamics allows you to explain why time flows in linear direction. It allows you to explain that why you cannot back in the time. Think about it. So very basic ideas about entropy and this interconnection with statistical physics, and you realize that this is a very, very fundamental subject and it can answer some really fundamental questions about nature of the universe. The good thing here is that in the subject you also look at some of the historical evolution, things like Gibbs phase rule, the idea of chemical potential, the idea of critical constants. अभी जो chemical potential है, इसको हम as a mathematical necessity की तरह treat करते हैं, but इसका खुद में एक deep underlying meaning है. जैसे chemical potential, जब when I was taught chemical potential, it was thought of as a like it's a mathematical necessity, and I'm fine with that, because in physics you do a lot of things which you realize that it is only because of mathematical necessity. But this has a deep underlying meaning which we should appreciate, and how it is associated with free energy. You also realize Boltzmann statistics, which you again have to study. So Maxwell-Boltzmann distribution of molecular velocities, equipartition virial theorems, Einstein-Debye theory of specific heat of solid. So you also realize that thermodynamics, of course, is not limited to gases. It is applicable to so many other different objects, including solids. And you realize Maxwell relations, different thermodynamic potentials, Maxwell relations, Clausius-Clapeyron equation, adiabatic demagnetization, Joule-Kelvin effect, all of those things, liquefaction of gases. And you start with ideal gas, you go to real gas, and then you explain each and everything here. So you start with very simple ideas, and suddenly you realize that everything which we have mentioned here, all of that can be explained with very simple ideas, just by first law and second law of thermodynamics. Now, statistical physics is again much more difficult subject, but for UPSC, the syllabus is very easy. You need to have very basic ideas about Maxwell-Boltzmann statistics, Bose-Einstein statistics, Fermi-Dirac statistics, and the ideas of black-body radiation which you learned, you again have to understand, connect that with ideas of thermodynamics. So even though when you study statistical physics in very deep, this is actually a very difficult subject, but for UPSC it is not. For UPSC it is like not very difficult, still mathematical, but not very difficult, okay? And I am going to recommend one book. I frankly am not a very huge fan, but for UPSC requirement, I think this is a good book. I will repeat, I do not think this book does the justice to the fundamental nature of the subject, which is called thermodynamics. But for UPSC requirement, I think this is a good book. So this is not a book about the beauty of the subject, but this is a book about the practicality of the subject for UPSC. So by Garg, Bansal and Ghosh. That it starts with kinetic theory, then it goes about thermodynamics, and it also has some dedicated chapters on statistical mechanics. So only in one book you can find all of the things. So quantum mechanics syllabus or paper 2 syllabus, how UPSC has defined it. and I have further like broken down the keywords. These are the main ideas which you need to learn. You need to learn about wave particle duality. You need to first appreciate Schrodinger equation itself. You need to understand the idea behind Hilbert space, Schrodinger equation, without going into specific problem. This is very important. Even without going, ये specific potential के लिए हम बाद में solve करेंगे कि free particle के लिए हम solve करेंगे, linear harmonic oscillator के लिए. These are specific potential problem. We should not start with that. We should first start with the significance of the equation itself. People often think that Schrodinger, जो quantum mechanics है, this is much more difficult. But believe me, mathematically it is easier. Mathematically, classical mechanics, especially when you study Lagrangian and Hamiltonian, it becomes much more complicated. But mathematically, this is easier because there are standard differential equations, and the best part is that you do not have to solve those differential equations. They were solved hundreds of years ago by mathematicians. You just have to write the solution. So mathematically, this is not a very difficult subject, but you need to be accepting of the fact that you cannot imagine this subject. You cannot imagine wave particle duality. You cannot imagine principle of uncertainty. You need to rely upon abstract maths. And even though math seems abstract, the conclusions are not. The conclusions can be verified into experiment. And that is the beauty of quantum mechanics. One of the most fundamental branches of physics at very, very basic level. So you start with first Schrodinger equation itself, and this is how I'm going to deal this topic, that not for specific potential. But then we are going to apply Schrodinger equation for specific potential, which is given in your syllabus. Free particle, particle in a box, particle in a finite well, linear harmonic oscillator, potential problem, reflection transmission, rectangular barrier. These are the specific potentials which you have to solve Schrodinger equation. But you also have to solve this in 3 dimension. So particles in a 3-dimensional box, that is a specific case. Density of states, free electron theory of metals. But you have to solve angular momentum problem, and you have to solve also for hydrogen atom. And the last topic is very simple, matrices. That when you study spin and Pauli matrices, you realize that quantum mechanics is a lot about linear algebra. So you should have good understanding of linear algebra also as a topic here. This is the easiest part of paper 2. जो atomic and molecular physics है, ये easiest है. ये theoretically भी easiest है और ये mathematically भी easiest है. But ये subject आप appreciate तभी करोगे जब हमारा ये part clear है. Only when our Schrodinger equation in 3D, when that is clear, when you realize quantization of angular momentum, when you appreciate the meaning of the quantum numbers, when you appreciate this part, then you appreciate atomic spectroscopy, and then you appreciate molecular spectroscopy. So in atomic physics, you start with first this very famous experiment, Stern-Gerlach experiment, and how that led to the idea of electron spin. And then you apply ideas of geometry in LS coupling, JJ coupling. So this is again simple vector analysis here. And very, very simple idea about spectroscopic notations of atomic state. And the only thing which is little bit more complicated, even this is not very complicated, diagrams may look very scary, but the ideas are very simple, which is Zeeman effect. So this is the simplest part of your paper 2. Same is even molecular physics, that you read about Frank Condon principle, rotational vibrational electronic spectroscopy, Raman spectroscopy, neutral hydrogen atom and its application in astronomy, fluorescein, phosphorocene, NMR, EPR, lamp shift. All of these are, except these two, all of these are very simple one-page physics. These two will require some, again, deeper scrutinization, including Frank and Condon principle, but other part is very, very simple and very straightforward. So this is the easiest part of paper 2, section B. And which also tells me that this is perhaps the difficult part of the section B. So nuclear physics है, उसका एक बहुत बड़ा कारण ये है कि अगर आपने फिजिक्स डेडिकेटेडली नहीं करा है मास्टर्स, आप जैसे आपने मास्टर्स करा है फिजिक्स में, फिर ग्रेजुएशन करा है, क्या है बैकग्राउंड आपका? बीएससी करा है, तो फिजिक्स आपने बीएससी करा हुआ है आपने, बीटेक किस चीज़ में किया आपने? सॉरी, अच्छा, तो जब तक आपने ये नहीं करा है, फिजिक्स डेडिकेटेडली नहीं पढ़ा है, देन आप न्यूक्लियर फिजिक्स नहीं पढ़ते हो. इनफैक्ट आप एटॉमिक एंड मॉलिकुलर, जैसे आपने क्वांटम पढ़ा होगा, वेरी श्योर कि क्वांटम के कोर्सेज किए होंगे, तो क्वांटम तो चलो फिर भी लोगों को आता है, 10+2 में पेपर 1 करीब करीब तो समझ तो है ही. यू डू नॉट नो एटॉमिक एंड मॉलिकुलर फिजिक्स, आपने पढ़ा होगा, लेकिन आपने एटॉमिक एंड मॉलिकुलर फिजिक्स पढ़ा होगा, आपने न्यूक्लियर फिजिक्स भी पढ़ा होगा, but you do not study that unless you have done a dedicated graduation level study in physics. Now atomic and molecular physics is easy because ideas are simple, maths is simple. Nuclear physics is not. In nuclear physics, you cannot appreciate this topic at all without having a very solid foundation of quantum mechanics. So section B of this topic is directly dependent upon section A, that you need to have a very solid foundation of quantum mechanics. Only then you can appreciate section B, which is nuclear physics. Nuclear physics is a difficult topic, but even within that, UPSC has streamlined the syllabus and very few things are given in your syllabus. Properties of nucleus, size, shape, charge. I feel that a direct jump into this discussion without understanding the historical evolution of things, that how people tried to know about size. मैं साइज लिख दूं आपको, मैं फॉर्मूला लिख दूं, बट हाउ पीपल इवन अप्रोच दिस प्रॉब्लम टू नो अबाउट साइज. Why I need to know about shape and charge distribution? What difference does it make that it is sphere or ellipsoid? What difference does it make that charge is uniformly distributed versus not uniformly distributed? So when you appreciate the significance of that, why we are trying to determine these properties, why are we trying to determine size, shape, charge, spin, parity, quadrupole moment also, then that is the beauty of nuclear physics, that you are trying to understand physics at one of the most smaller scale, femtometer, in the range of femtometer. At femtometer, what type of forces are operating? So you start with a very simple quantum state, which is deuteron problem, one neutron and one proton, and you find that what type of interaction is going on between neutron and proton. And you realize that even though there are a lot of approximations involved in this problem, even then it leads to so many correct conclusions, not of course everything correctly, but so many correct conclusions that it is remarkable. It allows you to appreciate that it is a charge independent force. It allows you to appreciate that it is a short range force, right? It allows you to appreciate that the potential well is much, much more deep, जो nuclear force का है. So very simple ideas lead to profound conclusions when you look at the final values which you have derived after solving deuteron problem. And then you immediately appreciate the significance of binding energy. And then you try to solve that binding energy with first starting with what we call liquid drop model. And then you elaborate around, you assume nucleus has a liquid drop and you elaborate that and you come to what we call semi-empirical mass formula. And you develop another model, shell model. जो combined model है वो हमारी UPSC syllabus में नहीं है. So इसका जो next part ये होगा that now we will study combined model. All of those things, सबका best चीज एक साथ हम लेके हम develop करेंगे. That part is not of the syllabus. Radioactivity के जो basic ideas हैं, it's just that जो हमने पढ़ रखा है 10+2 में वो तो यहाँ पता होना ही चाहिए. बट इसका जो फिजिक्स है, पर्टिकुलरली जो बीटा डीके का फिजिक्स है, वो इंपॉर्टेंट है बिकॉज बीटा डीके अकर्स बिकॉज ऑफ वीक इंटरैक्शन. इट डज नॉट इवन अकर बिकॉज ऑफ स्ट्रॉन्ग और इलेक्ट्रोमैग्नेटिक इंटरैक्शन. सो दिस यू शुड नो. न्यूक्लियर रिएक्शंस, टाइप्स, मैकेनिज्म्स, कंजर्वेशन लॉज, फिशन, फ्यूजन, दिस इज ईजी पार्ट. ये जो पार्ट है ये ईजी है. ये जो पार्ट है यहाँ से प्रॉपर्टीज ऑफ न्यूक्लियस, न्यूक्लियर फोर्सेज, न्यूक्लियर मॉडल, ये ईजी नहीं है. दिस विल रिक्वायर very good understanding of quantum mechanics and very good mathematical aptitude. Particle physics is easy. Particle physics बहुत ही important खुद में ब्रांच है, but ये easy है, ये मुश्किल नहीं है. Because इसका जो मुश्किल पार्ट है वो आपको पढ़ना नहीं है. जो particle physics का जो actual development है, this requires understanding of quantum chromodynamics. This requires understanding of Feynman diagrams. You do not have to go into such details. You study very basic ideas of particle physics. How do we divide fundamental particles? What are the parameters using which we divide fundamental particles? So we focus upon these things here. So this is an easy part of section B. If there are questions from particle physics in section B, I will immediately choose that question because it will not take a lot of time and you'll get a lot of marks in this part. This is a part which students tend to leave, but I don't think we should do that because you'll be compromising upon at least 20 marks if you leave this part. जो solid state physics, devices and electronics part है. The reason students leave this part, it's simple. It's huge. Syllabus is huge. Syllabus कहीं से कम नहीं है. And ऐसा लगता है कि काम चल जाएगा. मतलब 5 क्वेश्चन करने हैं, 3 हमने सेक्शन ए में कर ही लिया. एक क्वेश्चन 5 में एक क्वेश्चन छूटेगा मान लो. 4 तो कर ही लेंगे क्वेश्चन नंबर 5 में. एंड बाकी के 3 में एक कोई ना कोई क्वेश्चन मिल ही जाएगा जहाँ पे एटलीस्ट 2 क्वेश्चंस हो जाएंगे. So, but even then, you are at least compromising on 20-25 marks, which we should not. We should try to attempt all of the question. And I will also make a case that if you study this subject well, then you will have this tendency to attempt 3 questions from section B and only 2 from section A. That maybe there is a very complicated, जैसे मान लो हाइड्रोजन एटम का क्वेश्चन आ गया, एंगुलर मोमेंटम का क्वेश्चन आ गया, आपको पता है, बट आपको पता है कि पूरा लिखने में बहुत सारा टाइम लग जाएगा, 2 पेज का डेरिवेशन है, lot of time will be taken. Compared to that, यहाँ पे टाइम कम लगेगा. Compared to that, यहाँ पे बहुत सारे steps हैं जो आप आराम से skip कर सकते हो, and you can write the final answer immediately. So here, what you have to learn? You start with, our focus is to learn about crystalline system, but we need to understand the difference between crystalline and amorphous solid. But the subject in itself for UPSC is only going to focus upon crystalline solid. Once you understand the difference, then you understand different crystal systems, space groups. How do we know about those crystal systems? What type of methods we deploy to understand about that? Then we study the specific properties of solid objects, such as we study the band theory. Band theory हमने class 12 में भी पढ़ा था, but class 12 में हमने खाली final solution पढ़ा था कि band gap के हिसाब से हमने मान लिया ये कंडक्टर है, ये इंसुलेटर है, ये सेमीकंडक्टर है. यहाँ पे आप प्रॉपर क्वांटम मैकेनिक्स सॉल्व करोगे, यू विल फाइंड अ वेरी स्पेसिफिक टाइप ऑफ पोटेंशियल, यू सॉल्व दैट पोटेंशियल एंड देन यू कम टू दिस रियलाइजेशन दैट व्हाई इट लीड्स टू अ बैंड गैप विच इज़ वेरी हाई, विच इज़ मीडियम, विच इज़ वेरी लेस. सो सेम थिंग व्हाट यू हैव स्टडीड इन 10+2. In 10+2 you directly studied the conclusion. Here you have to go through the mathematical derivation. The actual mathematical derivation is very complicated, 4 पेज लग जाएंगे. But if UPSC asks, 1.5 पेज का derivation है. There are a lot of things. You simply have to write the potential, main step and final solution, and you will get full marks by the way. या ऐसा कुछ भी नहीं है कि आपने बहुत सारे पार्ट स्किप करें तो आपके मार्क्स नहीं मिलेंगे. फुल मार्क्स मिलेंगे आपको तब भी. बिकॉज जो सबसे अच्छी किताब है सॉलिड स्टेट फिजिक्स की वो कीटल है. एंड इवन कीटल हैज़ नॉट डिराइव्ड एवरीथिंग. Dr. Pillai has done, but Kittel has not derived everything. Okay, that is the first part, electronic properties of solid. Second part is specific heat capacity of solid, which you, by the way, if you remember, we also studied that in thermodynamics. So there is an overlap with thermodynamics here. Thermal conductivity and related properties, diamagnetism, paramagnetism, ferromagnetism. So this has relationship with electricity and magnetism, and overall origin of magnetism itself. So the understanding of electricity and magnetism will greatly help, and thermodynamics will greatly help in this part of the syllabus. This part of the syllabus, understanding of quantum mechanics will be very, very helpful. That particularly for band theory, understanding of quantum mechanics is going to be very, very helpful. This part, crystal system, recollect your geometry. That geometry is going to be very helpful. Right, vector algebra is going to be very helpful in this part. And then the rest of the part, again in solid state physics, devices, electronics, there are 4 main things. First is about superconductivity. Everything about superconductivity, Meissner effect, Josephson junction, as well as high temperature superconductivity. So this first 3 line is about superconductivity. Next is about semiconductors, intrinsic, extrinsic, working principle of PNP, NPN transistor. Next is about electronic devices. And finally, you have this basic idea about first Boolean algebra, and then basic ideas about microprocessors and digital computers. So if you do this well, there is somehow a misconception that ये बहुत time लगेगा इसको करने में. ऐसा कुछ भी नहीं है, बहुत time नहीं लगेगा. If you do this well, you will realize कि ये करना ज़्यादा आसान है compared to solving angular momentum problem. You will realize that section B करना ज़्यादा आसान है compared to quantum mechanics, right? Even though I know quantum mechanics, but वो करने में time लगेगा, ये मेरा कम time में हो जाएगा, ठीक है? So I don't think this should be skipped. Even this part should be done properly. And if I have to recommend books here, only one book for quantum mechanics and only first 5 chapters, that's it. Not the entire book, first 5 chapters. Quantum Mechanics by Griffiths. Best book ever written on quantum mechanics. Quantum Mechanics by Griffiths. Very crisp, concise, and lot of content you will find in Griffiths. So Griffiths का जो Electrodynamics का book है, Quantum Mechanics की book है, दोनों ही बहुत अच्छी किताबें हैं. And I have read other books also, and my favorite book has been Griffiths. How Griffiths approaches the subject of quantum mechanics. For atomic and molecular physics, 2 books. In fact, this is also going to suffice for both atomic and molecular physics. A book written by Rajkumar. But if you want some extra information about molecular spectroscopy, जैसे जो Raman spectroscopy वाले जो chapters हैं, या Frank Condon principle वाले जो chapters हैं, they have been dealt very beautifully in this book by Banwell. Molecular spectroscopy written by Banwell. For nuclear physics, only one book, very bulky but very few selected chapter. मतलब इसका 1/3 पढ़ना है हमको. ये बहुत ही bulky किताब है, मोटी किताब है, but इस book का हमको सिर्फ 1/3 पढ़ना है. Like लिख के 1/3 पढ़ना है. Very specific chapters we have to read, more than enough for both nuclear and particle physics. You can read S.B. Patel also, but S.B. Patel skips a lot of important ideas, which D.C. Tayal does not. And for solid state physics, and including magnetic properties, specific heat capacity, everything, Pillai. Even though my favorite book is Kittel, but this is like more, there are a lot of pictures here in this book. Like you'll have a very good idea about the crystalline structure, and the mathematical derivations have been done in complete entirety so that you know what to skip, right? So in terms of concept, I think Kittel is a better book, but nonetheless, this is also a very good book, and I will recommend that for solid state physics, buy this. For electronics, buy this. B.L. Thareja, A.K. Thareja, B.L. Thareja, a textbook of electrical technology, volume 4. You can buy this book. Everything जो कि हमारा electronics का syllabus है, that will be covered. This is not a very bulky book. Everything will be covered here. So this is about the books which we should refer to. मैं डायरेक्टली एग्जाम की ही बात कर रहा हूँ अब, बट हम जब एग्जाम में बैठेंगे, मेंस दे रहे होंगे, हम कुछ चीज़ों का ध्यान रखेंगे. एज आई सेड अर्लियर, 5 questions. To attempt, take some time to decide which 5 questions apart from 1 and 5. So you only have to choose 3. Out of 6, choose 3. And once you decide that, stick to it. Do not change in between. That will not be good. Start using calculator. So my plan is that every class I ask you to bring a calculator, and you solve questions using calculator in the classroom itself. Like every day you solve at least 1 or 2 numerical, that you become accustomed in using calculator. I do not want you to waste time in doing arithmetic. कि arithmetic में time नहीं लगना चाहिए, ये जल्दी से होना चाहिए. बहुत सारे formulas दे रखा होता है शुरू में, उसको जितना यूज करना है वो करो. 10 marker का क्वेश्चन है, जो अंडरलाइंग डेरिवेशन है कोई करने की जरूरत नहीं है. If it is a 10 marker question, directly use the formula. You'll have to remember some formulas. But बहुत सारे students को मैंने देखा है, last year test series कराया था, that even in 10 marker question, they're deriving things. Don't do that. Nobody's expecting you to do that. But once you derive, once you come to some answer, and you think that there is a physical significance of that answer, write that. ये मैंने लिखा है, whenever possible, write down physical significance of the result as well as the principles which you have applied to solve a question. ये आपका हर क्वेश्चन में 0.5 मार्क्स बढ़ा देगा. अगर ये आपने इंटरप्रेट कर लिया, इसको इनकॉर्पोरेट कर लिया अपने आंसर में, ये हर क्वेश्चन में आपका 0.5 to 1 मार्क्स बढ़ाएगा. जहाँ पे 10 में 6 मिलने चाहिए, 7 मिलेंगे आपको. If you do this, physical significance as well as principles. And wherever possible, make diagrams, graphs, wherever possible, wherever it is required, even if it is not being asked. If you think that making a diagram is going to make things visually appealing, add that. Physics, and the best part about diagrams in physics is that I do not have to exactly do my scaling. It is more about what the shape looks like, right? So ये diagram जहाँ पे भी possible हम बनाएंगे, this will further add 0.5 marks. तो ये दो चीज़ें हमको अगर हमने करना सीख लिया अपने हमारे आंसर में, तो आपके मार्क्स जो है आप 300 प्लस आएगा, आपका पक्के से आएगा, 300 प्लस आना ही आना है, वो 320 आए, 325 आए, बट ये दो चीज़ें अगर हमने कर लिया और हमने सारे क्वेश्चंस अटेम्प्ट कर लिए, 300 प्लस इज गारंटेड. सो दिस इज द ब्यूटी ऑफ दिस सब्जेक्ट, that it will take some time. So I mentioned this here, that why we should choose this subject. What are the reasonings behind selecting physics as an optional? Very high scoring potential. I would say after maths, this is the highest scoring subject. You can expect 320, 325 marks also in physics. And if you find top rankers in physics in top 20, let's say, you'll often find that they have scored more than 300 in the optional itself. So optional has played a significant role in their final selection. तो ये सबसे important part तो यही है कि बहुत ज़्यादा नंबर मिलेगा. और अच्छी बात ये है कि होपफुली आप एक अटेम्प्ट में ही क्लियर कर लो, बट अगर आपको नेक्स्ट अटेम्प्ट भी लिखना पड़े तो आप इसमें नहीं रहोगे कि इसमें क्या पता उतने नंबर ना आए, जो कि बाकी किसी ह्यूमैनिटीज़ में पॉसिबल नहीं है. आई नो पीपल हु स्कोर्ड 270 in sociology and next year they scored 200. I know people who scored 219 PubAd and next year they scored 170. So that will not be there in physics or in general for any science subject. Objectivity, that is a important part. We know what is the demand of the question. I know how I need to approach this question. I know the steps, I know the answer. In other subjects, very popular subjects in humanity, that objectivity will not be there, right? How you use current affairs, how many thinkers you are thinking, right? ये सारी चीज़ों पे डिपेंड करेगा कि आपके कितने मार्क्स होंगे, right? तो ये चीज़ें यहाँ पे नहीं है. सिलेबस स्टैटिक है. जितने भी पॉपुलर ह्यूमैनिटीज़ हैं सब में जो पेपर 2 है उनका बहुत सारा करंट अफेयर्स ड्रिवन है. आपके आंसर में करंट अफेयर्स होना ही होना चाहिए, कोई लेना देना नहीं है इसका. स्टैटिक सिलेबस है, फिक्स सिलेबस है, पिछले 15 सालों से फिक्स सिलेबस है, सेम चीज़ें, सेम टाइप के क्वेश्चंस आ रहे हैं. प्रिडिक्टेबल क्वेश्चंस हैं, क्वेश्चंस आर नॉट अनप्रिडिक्टेबल. वी नो विच एरियाज are important, we understand the trend, and based on that, even if I do, let's say for example, past 10-year question analysis, I have a very good understanding of the requirement of UPSC. And one last part, which is people do not think about it, but you can also appear for forest. The forest services में एक आपका fix हो गया, दूसरा forestry ले लो, आपके 2 optional prepare हो गए, और अगर forest के लिए तैयारी करोगे तो prelims के लिए और अच्छे से पढ़ोगे. तो prelims में forest का ज़्यादा आता है cut off. So you have better chances of clearing prelims examination if you also appear simultaneously for forest services. Okay. Why not physics as an optional? It's not easy. I will not say vast because vast तो सारे optional है. Political science भी vast है, sociology भी vast है. Maybe anthropology उतना vast नहीं है, but geography भी vast है. बट कॉन्सेप्चुअली कॉम्प्लेक्स है, राइट? टाइम इंटेंसिव है, सिलेबस खत्म होने में टाइम लगेगा, बट एक बार सिलेबस अच्छे से खत्म हो जाए तो आप आराम से 15-20 दिन में रिवाइज कर लोगे. ये है. मेंस जीएस में यूज नहीं आएगा आपके. मे बी इन सम कॉन्सेप्ट्स ऑफ ज्योग्राफी एंड सम कॉन्सेप्ट्स ऑफ साइंस एंड टेक्नोलॉजी और सम कॉन्सेप्ट्स ऑफ इन्वायरमेंटल साइंस, देयर विल बी सम एप्लीकेशन, बट मेंस में बहुत ही लिमिटेड एप्लीकेबिलिटी है कंपेयर टू लेट्स से व्हाट सोशियोलॉजी हैज़ or what PSIR has, or what even history has or geography has. So that is there, that you do not have applicability in mains examination. So if you feel that you have a strong academic background in physics or engineering, you have a genuine interest in the subject, you like the subject, you want to read more about the subject, and you have some aptitude for mathematical problem. Again, I do not want you to think about some complex combinatorics and number theory and probabilities. No, some very basic ideas of linear algebra, vector calculus, vector algebra, and you are comfortable in abstract space. Like if I tell you Hilbert space, that does not make you that what is happening here. So if that's the case, then go for this subject. Choose this subject, and you'll score really, really good marks. Remember that part. This is a high scoring subject. A good answer, which I was talking about, presentation matters a lot. Your answer should be structured. You should have clear labeled diagrams, well labeled figures, stepwise problem solving. ये important है. ये एक beauty ये है. तो अगर आपका final answer थोड़ा गड़बड़ हो भी जाए कि कुछ आपने गलती से कहीं पे लिख दिया, उसके कारण final answer गलत हो गया, बट आपके अगर steps correct हैं तो आपके 1-1.5 नंबर सिर्फ कटेंगे, इससे ज़्यादा नहीं कटेंगे. सो जहाँ पे 6.5 मिलना चाहिए वहाँ पे आपको 5 मिलेगा, बट यू विल स्टिल गेट मार्क्स. But if this is not correct, then that of course will not be beneficial. Time management is very important. That you should be very clear that first 2 hour में 4 क्वेश्चन 3 क्वेश्चन हो गए, even less than 2 hour, and बाकी फिर आपको लास्ट का जो एक क्वेश्चन है लास्ट के जो 2 क्वेश्चन हैं वो आपको करना है, सेक्शन बी करना है, या जो भी आपने 3 पहले करना है 2 बाद में करना है. दैट इसको मैनेज करना बहुत इंपॉर्टेंट है. दैट यू डू एवरीथिंग इन प्रॉपर टाइम. यू डू नॉट get stuck in one question, and if you feel that you are getting stuck in one question, go to the next question, because that will lead to a slippery slope. So that is not a very good idea when you're appearing for the mains examination. Books I mentioned, which are the books you should refer to. Let me show you. I will come back to this part later. This is the last part of the presentation, but I have some for example, I have when UPSC asked this question, I took a session where I had provided the detailed solution of the 2024 question paper. That, let me show you in fact the question also, so that you have some idea. Of course, I cannot show all the question. I will get it uploaded though.
Preparing for the UPSC Civil Services examination demands a solid grasp of every mains paper. Among them, the optional subject paper plays a crucial role in determining your final rank. A strong command over your optional subject can give you the competitive edge needed for success. To help you master this crucial aspect, Vision IAS presents the Optional Classroom Program 2026, available in live online and classroom offline modes for Geography, Sociology, Political Science and International Relations. Batch starts from 20th June, 2 p.m. Looking for expert mentoring to crack UPSC? Lakshya Mentoring Program is your answer, a personalized, expert-led path from preparation to performance. If you are targeting Prelims 2025, here is what is in store with batch starting from 14th March. One-on-one mentoring with UPSC experts. Tailor-made strategy to match your needs. Regular MCQ-based assessments, CSAT support. Access to live quiz, Sandhan personalized tests, Lakshya Prelims practice tests. Planning for the long game Prelims, Mains and Interview 2026? Lakshya Integrated Mentoring Program 2026 gives you a head start with batch starting from 15th March. Year-round mentoring support, structured preparation calendar. Prelims to interview coverage including GS, CSAT, ethics, essay, and personality test guidance. Regular evaluation, customized feedback, and adaptive planning. Regular group and one-on-one session with mentors. Integrated current affairs preparation with digital current affairs platform.
So this is the past 3-year question. Let me directly go to the end. Okay, so even a 10+2 student will be able to easily solve this question. Having an initial velocity v0 subjected to a retarding force proportional to its instantaneous velocity, obtain the expression for the velocity and position of the particle as a function of time. Very simple question of time evolution of things. I make a simple diagram. At time t is equal to 0, I assume velocity v0. At time t, force is minus kv, right? I write Newton's second law, I solve it, I find a solution. I make certain assumptions. At t is equal to 0, v is equal to v0. I derive this and I make the diagram. This is important. So this is what I was talking about, that I make the diagram. Even though UPSC is not asking it, I derived this, that v is equal to v0 e raised to the power minus k by mt, but then I make the diagram. Right? To calculate x, I again integrate it. Here again I assume I have to write my assumption. So for example, in this case I assumed that at t is equal to 0, x was 0, and then I calculated the second constant of integration, and this is my formula. So if I start with x is equal to 0, then this is the maximum displacement I am going to achieve, but in infinite time. This will be an asymptotic, I will never be actually able to reach that. So I make this diagram also. So add diagram, that was my point, that even in doing this, everybody will do that. ये तो बहुत simple सा question है, but add diagram. That was my point. So wherever it is possible, add diagram. Wherever it is possible, mention everything, mention the physics behind it. अब जैसे अब यही, लेकिन जो एक और क्वेश्चन है, let me show you this question. A charged pi meson with rest mass, this decays into this. Find the kinetic energy of mu meson, energy of the neutrino. You will realize that if you simply do the algebra, that will take some time and some space, right? So all I have done here is that without writing a lot, I have written this. I have simply mentioned this is due to energy conservation. So even writing that is going to be helpful. Just mention, or I could have used as per energy conservation this. And I have also made one more assumption, assuming neutrino to be massless. So please always do that. Whenever you are writing assumption, always do that. And then you apply momentum conservation and you write, you come to, you do algebra and you have your answer. अब यहाँ पे कुछ नहीं करना है ज़्यादा. ये तो आंसर है, algebra था. जो भी हमें assumption लेना था, law लिखना था, वो हमने ऊपर लिख दिया है. Let me show you some questions from जैसे optical activity. This question 3A2. So again, I explain optical activity. I यहाँ पे explaining everything properly. Linearly polarized light can be considered as a resultant of two circularly polarized light, right and left. I explain that. Then I develop the mathematics, apply the formula, I get the answer. So the point is that I always and always, wherever it is possible, I will try to make diagrams. I will write the laws of physics. I will write my assumptions, and if possible in the end, I will write the significance of the formula final equation which I have derived, right? तो ये हम अगर करेंगे, I will get extra marks. And if you do that, you can easily expect very, very high marks in each and every question. And it is not a very difficult thing to achieve. Let me show you a few things from paper 2 also, in fact. इजी क्वेश्चन है, देखो. वेव फंक्शन दिया, प्रोबेबिलिटी निकालना है, एक्सपेक्टेशन वैल्यू निकालना है. So simple such type of numericals you expect in question 1, which I was talking about, that in mandatory question you expect such type of simple numerical. So पहले तो I know that wave function is not normalized, so I need to normalize it. ये पूछा नहीं है, but अगर आप नहीं करोगे तो नंबर नहीं मिलेंगे. So you need to normalize wave function. For that you have to calculate B, and once you normalize it, then you calculate probability. ठीक है? तो ये करना ज़रूरी है. Even though normalization was not asked, but it was inherent that you have to first normalize it. In any case, you cannot answer this question if you do not normalize it. This is a standard derivation. Look at the second question. So I said that even in 10 marker you expect standard derivation, but this is a simple derivation. Show that square of orbital angular momentum commutes with any of the components of angular momentum L. Is it possible to measure all of this simultaneously? Give reasons for your answer. And I have to explain this. So पहले तो हमने दिखाया कि commute 0 है, and ये भी दिखाया कि because Lx, Ly, Lz, Lz, Lx नहीं करेगा commute, together cannot be simultaneously measured. So I need to explain things properly. Anyways, so this is, I'm going to get this uploaded also so that you can look at the model answers and how you answer questions in mains examination. How I approach to take this? The first thing that I am going to teach both paper 1 and paper 2 simultaneously. So if I have 5 classes a week, then 3 classes paper 1, 2 classes paper 2. If it is 6 classes a week, on some weeks there will be 6 classes, then it will be 4 for paper 1, 2 for paper 2. So 2 classes for paper 2. Paper 1 will start with classical mechanics, paper 2 will start with quantum mechanics. However, the progression of the topic will not be the same as the syllabus mentioned, because I feel that this is the natural progression of the topic. That while I start classical mechanics and special theory of relativity, I will take about 14 lectures for that. But immediately, I will not start optics. I will start electrostatics and magnetostatics. Then I will teach electromagnetic wave and radiation. Then I will teach thermodynamics and statistical physics. And then the last part will be waves, interference, diffraction, geometrical optics and modern optics. So this will be the progression of the paper 1, right? In paper 2, progression will be the same as given in the syllabus. While classical mechanics classes will start, quantum mechanics will also start. After that, we'll study atomic and molecular physics, then nuclear physics, particle physics, solid state physics and electronics. So paper 2 ka jo progression hai, that will be same as it is given in your UPSC syllabus. But in paper 1, I have made certain changes that how I am going to approach subject by subject. So classical mechanics, then electrostatics and magnetostatic, but simultaneous classes for both paper 1 and paper 2. Once we complete the syllabus, few specific classes जो भी फॉरेस्ट सर्विसेज के सिलेबस में है, करीब करीब 90% सिलेबस सेम है. देखा आपने फॉरेस्ट का सिलेबस, तो 90% सिलेबस सिविल सर्विसेज का और फॉरेस्ट सर्विसेज का सेम है. बट देयर इज अ 10% डिफरेंस, एंड फॉर दैट 10% डिफरेंस वी विल हैव सम डेडिकेटेड क्लासेस. जैसे इन क्लासिकल मैकेनिक्स वहाँ पे लैग्रांजियन है, फॉरेस्ट वाले सिलेबस में आप देखोगे तो वहाँ पे लैग्रांजियन हैमिल्टोनियन मैकेनिक्स पढ़ना है आपको, प्रिंसिपल ऑफ लीस्ट एक्शन पढ़ना है वहाँ पे. सिमिलरली आपको थर्मोडायनेमिक्स में शाह इक्वेशन पढ़ना है. सो देयर आर फ्यू थिंग्स which is not here. Similarly, in civil services, there are few things which are not in the forest services syllabus. So that part which is overlap, which is not overlap, we will have some exclusive sessions for that. No shortcut. I don't believe in skipping any topic. I do think that we should cover topic from every topic should be given weightage, including complex topics like statistical physics, electromagnetic theory, nuclear and particle physics, right? Model answer of last 10 years. What I showed you for 2024, for every year, model answer of last 10 years. And every day, few questions in the class at least, mostly from PYQs or standard book, but weekly tests also. So these are some of the things I plan to implement. So every day I am going to expect students to bring calculator, one extra notebook along with notebook जहाँ पे हम notes बनाएंगे, but one extra notebook जहाँ पे हम सिर्फ numericals के लिए रखेंगे. So this is how I plan to touch this topic, start this topic. If you have any questions, you can ask questions about the subject, about the classes, about the preparation in general. If you have questions, you can ask questions. I think 100 classes. So if I start 20th of July, by December it will definitely be completed. So by end of this year, the syllabus will be completed. That is the time frame. I will not say 4 months. That I don't think that is possible. 100 classes, Most of the weeks there will be 5 classes, I would say. In some weeks there can be 6 classes also. But every week there will be test will be separate part, right? I'm only talking about classes part. So 100 classes. During as the classes are happening, as they're happening, I expect you to spend every day at least 1 to 2 hours, minimum 1 hour for revising things. But as we progress more and more, 2 hours, because then you'll have more and more to revise. So in starting 1 hour, but as we progress more and more, because you also have to revise few things, 2 hours. But if you do that, if you take that time during those classes itself, that revision part, then after that the revision will be very simple. After that, I don't think it will take more than 15-20 days for you to cover the entire syllabus. And once you do that thrice and 3 and 4 times, you will yourself make some formula sheets for each and every topic. Yourself will attempt questions. You'll be prepared. So my plan is that by January you become prepared really well. So by December itself you become prepared well, but you get enough time for prelims examination, that after February you do not have to worry a lot about optional. So that's the plan. Okay. Any questions if you have? Okay, that's a very good question actually. That's a very relevant question. Don't go into a rabbit hole. What do I mean by that? It's a very interesting subject, right? I start teaching you quantum mechanics, I start teaching you, let's say, unification ideas. Particle physics का syllabus है ना? That you are also supposed to know about elementary knowledge about electroweak theory, unification, ideas of unification, which is what quantum chromodynamics is. Although this word is not given in your syllabus, I have added this word. So don't go into those rabbit holes. Just I mentioned Noether theorem, but don't go into that rabbit hole. As a faculty, I will do that. I will mention those things. How much is required? How can we use this in answer? I will mention that. But don't go into rabbit holes. ये बहुत important है. The point I'm trying to make here is that you have limited time frame to prepare the subject. Utilize that time very wisely. So you have to prepare your GS also. So it shouldn't be then only about physics. So that is the first mistake which one can do, that you become enchanted with this subject, which is, by the way, a very good thing. But then you also ignore your larger goal here, which is UPSC preparation. Okay, so we have to appreciate this subject, but within the framework which we have to prepare. I don't want you to think about this subject that I need to mug up things. I actually want you to enjoy this subject, right? तो पहला तो ये है. दूसरा ये है that do not get trapped by mathematical complexity of things. That if you try to mug up things, that ये हमारा आंसर है, ये final answer है, without understanding the physics behind it, that will be a problem. Only when you understand the physics behind things, only when you understand that I made a graph and this graph has a particular significance, only when you appreciate that, and then the subject will be enjoyable and you will come again and again and revise things for your preparation. So that is the second thing which I will ask you to not do. Okay. Also focusing on lot of sources. That is why in the slides also I only mentioned few specific books. So for almost every topic I have mentioned only one book. For few topics maybe 2 books, but for almost every topic just 1 book. Okay, this is how we should approach this topic. Any other question? If you have a question about this subject, about the preparation, feel free to send me a mail. All the best, guys.